I'd like to talk about some surface construction techniques, and one involves building past the theoretical with a slab or to the theoretical with a slab. And there's two schools of thought. I don't think we could say one is 100% right and 100% wrong. I'll tell you the one that I prefer. Here we have some quality surfaces, and by quality I mean this surface has nice curvature in two directions. We'll just show some combs here. So it's nice in this direction. Maybe we make this 6 and 6 so we can just see some shape here. That's pretty nice curvature and pretty constant curvature. If we switch now to this surface and we look, we have kind of an accelerating curvature at the outboard side, right? And then if we look in the opposite direction, we've got pretty nice acceleration at the front side. So two good surfaces. Well, the issue that you can find is two good surfaces may not produce a good intersection. And what is not a good intersection? Well, in this view, this intersection has compound or two directions of curvature, positive and then negative. Okay, and as I roll this around to a more front view, you can still see here it's crowned this way, here it's crowned the opposite way, but somewhere in the middle it's an S. There's never a flip-flop. Okay, so that's a difficult thing to judge and a difficult thing to modify using overbuilt slabs. This brings up why I like to use build to the intersection and then modify when necessary, as far as extensions and other things. So how can we get this built to theoretical intersections? I'm going to use the Surface Edit Trim Convert tool and simply click on these surfaces. This quickly reconstructs those surfaces into their kind of raw shapes and tries to approximate all the boundaries. So if we do a continuity check for tangency, or for position, I'm just going to use positional continuity, turn all my locator things on, options on. So persistence, it stays on. Max labels shows me the min-max. Comb shows me a graphical representation. And we check this edge. We're off by almost 5 millimeters. Okay. So what I'm going to do now is I'm going to modify the side surface. I tend to like how this curvature is accelerating at the front. And if I had to go 5 millimeters left, right, up, down, I would probably start by moving these rows. Since this looks like the tangency is the same as this, I would probably move this surface to match this surface. So I would do that using the Object Edit Align function. And I will select this surface for modification and the other surface as the parent. Now if I bring this to 0, it tries to maintain the original shape, oddly, and match to the new shape. Well, it's doing it in this case by inserting a lot of spans. If I turn on explicit control, it tries to maintain this control vertice as close to the same position, yet gaining more continuity. Okay, if we revert and we check the continuity, it's 5 millimeters. And if you look at these CV locations, and just to be a little more precise, it's hard to tell if things are parallel and how they move when you have perspective. In this case, it looks like this row, and this row, and this row are all converging at a point somewhere over here. But if I turn off perspective viewing into orthographic, now we know that those are parallel. This is a key concept for, I think, analyzing CV structures, which is what we're going to talk about quite a bit. I'll Object Edit Align this again so we can see the results. Bring these together. It relatively keeps this in the same spot as the original. It's just moved it to be on plane with the other curve. I'm going to slide this to 1, which means the Align function has full control over its position, so it moves it exactly. Then I'm going to blend a couple rows with, so I'm going to blend 1, 2 rows, and I'm going to blend it with 0 blend factor. which means it will move at the same amounts. Now I've kind of taken this section from over here and just moved it all forward, okay? Yes, it changed the shape of the side. More importantly, we're fixing the relationship between this crown and this amount of crown to produce a pleasing shape along this edge, okay? Next, I'm going to go to the front view, okay? This is where we have an S shape, right? And I don't like that S shape. And I'm going to try and correct it a little bit. And my first correction would be if I look at this straight in the front view and I use my non-proportional scaling tools and I look at the angle of this hull, they all seem parallel. Then I look at the next row. They all seem canted a little bit. Then I look at the next row and I have down, down, down a lot, down a little less. That's what needs to be analyzed. These rows determine the crown or the curvature. I'm going to turn on my non-proportional view scaling just to illustrate this a little more. You can see here now how we've over-exaggerated that, and you can see the problem. What's the solution? I'm going to grab a control vertice with parallel, grab this control vertice and slide it along this hull. Okay, and it lets me do it. And I'm going to get this so that it looks a lot more straight in this view. Yes, I'm modifying this surface, no doubt. Okay. Then next I'm going to modify this curve, and I'm going to slide it out a little bit. No doubt modifying the surface. But now these control vertices have an ordered structure where it looks like the crown is accelerating out towards the same side, and we're getting a more planar curve in this view. Next, I would turn off my non-proportional scaling view, and I'm going to put this on what I think is a nice flat plane in a view. Okay, so I'm using the right mouse button to twist on the screen, left mouse button to rotate. We can use these twister dials. So now I can pivot right around the top of the screen and get this almost parallel. Okay, so it looks almost straight. Go back to twist. Okay, I just need this twisted just a little bit. You have to get this as close as you can to looking good. And then I'll do a surface edit planarize hull. I'm going to use adaptive, which just means approximate, and I'm going to use this edge. It's now made it planar in this view. This surface is still following, okay? So now if we look at this shape, and I'll turn off all these diagnostics, now this shape is positively crowned, perfectly flat, negatively crowned. Okay. Yes, we've deviated from the original. How much at this point I don't think is important because we're improving on a shape. Okay. As long as we're not totally radically changing what these shapes are, we need to improve and fix these theoreticals. That's part of the job. Okay. Next, I would take the Surface Edit Planarize Hull tool. I'm going to use Closest Boundary now, which is going to slide the CVs along the hull to the closest boundary. And I'm going to select this hull to planarize. Now, I think we have construction history on here, so I'll delete construction history, yes, because these were being moved by the alignment. And now I can do a planarize hull, and we get a nice fit, okay? Now, when I just look at this CV structure, I notice some tension right here. We have flat to positive, and then we have an OG. I just want to take this control vertice, move him up a little, maybe move them both down a little. Object Edit Align. I believe that this surface has the proper amount of crown. This surface should meet it. I'm going to turn off blending, off explicit control, set this to 0. It adds a row in. And now we have some very precise theoreticals controlled, planar in a view. While there is some deviation, we could now go and begin to minimize that deviation while keeping track of the nice structure that we've set up. And the real difference that I wanted to show, no matter how far off this is, if you look at it now, you can see how the green would be much more pleasing than the OG. And the real key is that if we now applied a blend to this, so a surface fillet between these two main slabs, and maybe we make this 150 with curvature. Okay. Let's put this to edge align so we can trim these surfaces. Let's do the same thing now to our converted version. Surface fillet here to here. Okay. Edge, edge. Okay. Now we should be able to toggle between the two and read some differences. So I'm going to turn on my ISO angle tool and set it to multiple rainbow, maybe this many bands, and I like about just some blur, maybe 0.1 blur. Just softens it a little so you're not too crude, too picky. And if we look at this in the front view, and now we switch between the two and switch this to ISO angle, now by toggling you can see the difference. One is an S-shaped highlight, the other is a more controlled highlight. Okay, so in these views, this is an S, this is more controlled. Over here, flat to sharp, more controlled. From this view, more acceleration, flat, a little nicer. Great, let's try it.